Why should I have a VFD on my unit? What are the advantages of having a variable frequency drive? The first thing is the control starting current. On a standard motor, it takes 7 to 8 times the full motor load current to start the motor. This current stresses the motor windings and generates heat, which over time reduces the life of the motor. The VFD controls the acceleration of the motor. The motor ramps up to running speed rather than coming on right away. A VFD adjusts the operating speed. Frequency can be controlled to control the operating speed of the motor. A VFD also controls the stopping of the motor. The big advantage of a VFD is the energy savings. VFDs can reduce energy use by 45%. At a utility rate of 10 cents per kilowatt hour, annual savings could be around $5,000. A call that we frequently get in tech support is the VFD on my unit has failed and we can't get a replacement drive for 2 months. What are we going to do? The simple answer is bypass the drive. In many applications, the VFD is not absolutely necessary, as the fan is usually run as a constant fan and never shuts off during business hours. Many comfort cooling applications have constant fan requirements also. In these cases, the only thing lost by bypassing a VFD drive is the energy savings. The VFD drive may be bypassed until the new drive arrives, and in some cases the building owner may decide to operate the unit without the VFD drive and keep it bypassed. Here's a typical wiring diagram of wiring to a VFD and to the indoor blower motor. Normally, the wiring goes to the VFD to power the VFD, and once the VFD is powered, then it sends power out to the motor. When you bypass the VFD, you simply take the power around the VFD, or bypass it, and send power directly to the motor. In some cases, you may have to add a contactor to do this, but in many units, the contactor is on the supply side of the VFD, so that when the contactor pulls in for the fan to run, power is supplied to the VFD. If this is the setup that you have on the unit that you're working on, then it's simply a matter of just switching the wires from the VFD to the motor, and once the contactor pulls in, power is supplied directly to run the motor. Again, this is a diagram out of a major manufacturer's service and technical book, and it shows the bypass wiring for different sizes of VFD. In the top example, this is how the VFD is normally wired, with the wiring coming directly to the VFD and then onto the motor. And then when you bypass it, you're simply taking the wiring away from the VFD and sending the power supply directly to the motor. And also in the bottom diagram, the same thing. Taking the wiring coming from the control box or the contactor and wiring it direct to the fan motor to run without the VFD. We have been talking about physically bypassing the VFD by taking the wiring from the VFD drive and taking it directly to the motor. In some industrial applications, VFDs are supplied with a bypass, so that if there is a failure or we do not need the VFD to function, it can be automatically switched in the box that is below the VFD, so the VFD is taken out of the picture and the motor is controlled directly from the contactor.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.